Hello everyone. Today's lab is about reading and constructing graphs. So pretty much like in today's experiment or lab session, some of the objectives that we are intending to cover are the following. So those are the objectives. The first is to identify graphs. Then second one is how to calculate the scale of a graph, how to determine the different coordinates, how to find the trend line, how to calculate the slope of the trend line. We'll design a convenient scale for a graph, annotate the graph with title, axis names, units, and etc. Then we will learn how to plot a graph and how to construct a trend line. So today's experiment, what you need is like a transparent ruler and a graph paper. So the theory, the first part is what we are going to talk about is parts of the graph. So for instance, if somebody gives you a graph and their graph has like different parts. So the first one is like, for instance, the axis. So a two-dimensional graph has always x-axis, which is represented at the vertical axis. We call it, sorry, it's the y-axis. And then there is a horizontal axis. We commonly call it the x-axis. Then on the x-axis, what you have is like you have data values, like that you put on the horizontal axis values, and then likewise you have the vertical axis values, and then you have x-axis name, and then in addition to that you need to include a unit for that. Okay, a physical quantity. Every physical quantity has to be expressed both in names and symbols, and then units, so you need to include units. And then there is a vertical axis or a y-axis name and unit. In this example, it's distance and the unit is meter. Then in addition to that, like graphs have grid lines, right? So sometimes we call them like major grid lines, so some like the dark square things that you see, like for instance, this is one huge grid square that I represented. It's marked by the bold vertical and horizontal lines, and that represents the major grid lines. And then in addition, there are also minor grid lines. Those are grid lines that just, tell you a quick reference of like how every little square represents, how much value does it represent. Those are pretty much what the parts of a graph look like. Then how do we normally extract information from a graph? Like how do you find a certain value on the graph is the second item that we are going to talk about in today's experiment. So for example, if I give you like, as you can see in this graph, if someone asks you like at 10 seconds, what was the distance or the location of the car, then how do you represent it? So the first thing that you need to do is you need to locate where a value of 10 on your x-axis is, and then once you locate that value, the next thing that you need to do is like you draw a vertical line towards the graph. Okay, and then when you meet the graph, then what you will do is you will draw a horizontal line, as you can see here, across the graph, and then locate the point where that graph meets, that horizontal line meets the vertical axis. Then that is the value where what you get for a given or for a requested value of time. So in this particular case, if someone asks you what was the distance traveled by the car after 10 seconds, then your answer should be 65. Okay. There is also a similar kind of example here. If someone asks you like what is the distance covered by the car after 26 seconds, then you will come and first meet 20 seconds on the time axis, in this particular case on the horizontal axis. Then from there you draw a vertical line until you cross the trend line. Once you have that, what you're going to do is like you will draw a horizontal line from starting from the trend line until you meet the vertical axis. Then once you meet the vertical axis, then that's where you are going to find your corresponding value for that particular time. So after 26 seconds, then the car traveled 130 meters. Then that's how you normally extract information in a graph. Okay. Then the next item is like, how can you calculate the slope of a graph? The slope of a graph can be found by just simply using the formula. As you can see here, slope is equivalent to rise over run. Rise means how much value did you move in the vertical direction. If you take 2 points on the trend line, so keep in mind every time when you are calculating the slope, the values must be taken on the trend line. Don't just simply randomly take your data points, because your data points might not really represent the whole average or the trend line. Okay, so therefore slopes must be calculated based on the value that are obtained on the trend line. So the first thing that you need to do is you need to pick 2 points. As you can see here in this particular example, you have 2 points, that is 0,15. That's one of your points, and then you pick another point. In this particular case, as you can see here, this is the last point, this is your second point, right? So you pick your second point, and your second point is now, it is as 60,280. So sometimes, like if you prefer in terms of mathematics, you may consider this like as your x1 or y1 value, and this will be your x2 y2 value, because most of the time like we are very much inclined to represent things in terms of x and y. That's why I represent them as x's and y's. They're also put in this formula, as you can see here, y. Then your rise value will be how much value you moved in the y direction. Then that will be, of course, it's y2 minus y1. And then how much did you move in the x direction? That's your run value. Then that will be your x2 minus x1. Okay, then you already have your y2 and your y2 is 280. I'm just repeating this, whatever is written up here. Okay, minus 15. Then your x2 range is going to be from 60 to 0. So if you simplify this, then definitely you are going to get like 4.42 meters per second. Always a your slope calculation also needs to include units. Your rise values are represented in meter, and your run values are represented in seconds. So therefore your slope will have the combination of the two units, like meter per second. Okay, the second item, the third item, is how you can construct a graph. So how do you construct a graph? Like constructing a graph, sometimes like it has to be a reasonable kind of graph. What do we mean by that? Like let's assume that like your graphing area is this much. Okay, so your graph sometimes like it can only just it may only like occupy this much of the graph paper. This is not a good kind of graphing. Or sometimes like you may have a graph depending on the data where you start and where you have. If this is your graph paper, your graph may only occupy this space. This is not even the right way of like having your graph, nicely plotted. So therefore, a good representation of a graph at least should occupy at least 50% of the graph paper. Somehow, something like this is like a good graphing style. Okay, so therefore, how do we sometimes, like, you may wonder that, like, then how am I going to end up with this? So the first thing that you need to do is you need to find a convenient scale for your axis. For your x-axis, you need to find a convenient scale. You need to find a convenient scale for y-axis. So you may wonder that, like, how am I going to find this? So we made this thing like pretty much, very straightforward as much as possible. So what you need to do is, like, you need to calculate a design scale, or the scale of the graph in the x-axis and scale of the graph in y-axis. So the process is as follows. What you need to do is, first you need to find the range of your values. What is my minimum value and what is my maximum value? Then you take the difference between the two values, then that will give you like what would be the range of the data. So in this particular case, the minimum is 10, the maximum is 50 for the x-axis. Okay, so the data is provided in a table. You will see it like in a moment. So therefore, then your x range is this much. And then the second item that you need to look at is like, how big is my graphing paper? That means you need to count the number of small squares or small grid lines that you have in the x-axis. For this particular example, you have 30 of them. Then what you are going to do is, the next step is like whatever you found in the first step, which is in this case 40, right? Your data range, divide that by the number of divisions or little squares that you have on the graph paper and along the x-axis. In this particular case, it's going to be 30. So you divide 40 by 30, then what you get is like 1.33 per division. That means, like, so I'm just giving you an example. So if you have those squares, little squares, right, then in this, according to our calculation, this point, the first point, should be 1.33. Then the second point has to be 2.66. The third point is going to be 3 times the division. But if you pay attention, this 1.33 is not a convenient kind of divisioning, right? So therefore, it's better to have it like to a certain kind of a number that is as close as possible to 1.33. Then always we scale it up. So now in this particular case, what we got is 1.33. Since 1.33 it's a fraction, and it's like something that's not really representative of like a scale that can be graphed easily, then because the first point is 1.33, the second point is 2.66, the third point is going to be 3.99. Then after that, you will have to, oh my god, then what value should I put in? Then to avoid that, like, you need to pick up a proper value. So something larger than 1.33. Here are a few examples. Then in our particular case, something that is more than 1.33 is a 2. A 2 is a very nice division for our x scale. So you pick, then if it is a 2, it's easy like to remember. The first one is 2, the second one is 4, the third one is 6, the fourth one is 8, 10, and so on and so forth until you reach to your maximum range, which is a 50. Okay. So, and then you do the same thing like for the y-axis. You get your minimum value, you get your maximum value, you take the difference between the two, which is the range, and then you count the number of divisions that you have. You take the ratio between those two values, then automatically you get 5.8 5.83. If you look at 5.83, it's not really a good division as I explained it in the previous example. So look for something that is larger than 5.83. So you can come and look at like a number that is above 5.33 in this range or in this example data table. So a good number would be like a 10. So a 10 is a very convenient kind of scaling for your y-axis, which is easier, like 10, then 20, 30, 40, 50, and so on and so forth, as you can see in this example. Okay. Then having said that, then the next step is going to be how are you going to plot your values. Then what you're going to do is like once you represent your x and y values, as we already mentioned it earlier. So in the time scale, what we said is like 2 is a good scale, 2, 4, 6, 8, 10, right? So most of the time, like you don't need to write all the individual values as you can see here. Rather, like you can plot them at every you can number it at major grids like 10, 20, 30, 40, 50, and 60. Once you do that, second, and then in the y-axis we already chose a scale of 10. Then it means like this is 10, this is 20, this is 30, and so on and so forth. Then you have 50 here, 100 here, 150, 200, and so on and so forth. Once you have that, the next item is going to be you pick your x value. So in this particular case, like, you pick your data value on the x-axis, and then for instance, like at 20 seconds, like what is the value of the y-axis or the distance. Then you draw a vertical line, right, until you have that corresponding value. Then for instance, in this particular case, you locate 20, you mark it here, and then 93, you mark it here, and then you draw a horizontal line like this, and then you draw a vertical line like this for 20, and the point where those two meet, then that is your first data point. Then likewise, you keep on doing this like for the rest of your data pairings. Once you have that, the next item is going to be to draw your trend line. How do you normally draw a trend line? So a trend line has to be a line that is as much as possible closest to all your data points. It might not really pass through like the individual points. Like for instance, you may have data here, data here, data here, data here. Then your best fit line is going to be a line that is representative of everything. Maybe this is not a good trend line. Maybe a better trend line can be something like, something that goes somehow like this. This is not a good trend line. Okay, so therefore a trend line, it shouldn't really necessarily has to pass through everything. Okay, then all right, having said that, like then in today's experiment, what are the things that you will be expected to do? So the first part is, as we said, you will be asked to extract information from the data. Okay, so for instance, name the variables representing the x and the y axis. You look at the names, so like for instance, x on the x-axis, this is the name. On the y-axis, this is the name. Okay, and then of course number 2, it's asking you what are the units on the x-axis. So the units on the x-axis is this is the unit on the x-axis, and this is the unit on the y-axis. Okay, then third, number 3 asks you like calculate the scale that was used in the x and y-axis, show your work. So pretty much this is pretty much straightforward. You can see here, like for instance, this is 1. From here to here, how much distance did you come? You came like how much? 1, right? But if you look at like how many grid points did you pass to reach 1, then you count it like 1, 2, 3, 4, 5, 6, 7, and so on, 10. Right? So therefore, what's going to happen is like you have 1 for 10 grid points, then divide that by the number of divisions. That's what your scale is going to be, right? So therefore, that is your scale on the x-axis. You do the same thing in the y-axis. You count how many grid points you pass until you see your first reading, or 1, 2, 3, 4, 5. I had to count 5 grid points to reach to 5, right? So you have 5 values for 5 divisions. So therefore, this is going to be your y-axis scale calculation. Okay. And then this is like fill the following table with the values, elongation, and force for the first and last data points. So the first data point, as this is like reading graphs. So your first data point is, this is your first data point. If you draw a vertical line like this, then you will be able to read, your x value or your elongation value. If you draw a horizontal line like this, then you will be able to read your y value. So therefore, this is your x value or elongation value, and this is your y value. Okay. And then for the last data point, if you look at it here, this is what you have, right? So therefore, if you draw a vertical line that runs the whole way down here, then this will be your elongation value, and then this is going to be, you draw a very nice horizontal value, and then I think then approximately this is what your value is. Okay, you count it like 140, 40, 41, 42. Approximately that is what is going to be your last data point. Okay, then number 5 is asking you like what value of force is depicted by a trend line for the elongation 7. So as we said it, like first, where the elongation is on the x-axis, and then second item, what you look at it is like, what number am I referring to? 7. So you come to 7, right? So 7 is right here. Then you draw a vertical line from 7. So you draw a vertical line, and then until you meet the trend line right there. Then once you have that, like you need to draw a horizontal line like that, right? Until you meet the y-axis. So as a result, this value is going to be your corresponding value for 7. Okay, so you fill it here, and then for force, find the 36 value and then your predicted elongation. The way you will proceed is like you draw a horizontal line from starting from 35 until you meet the trend line. Once you meet the trend line, you draw a vertical line like this, and then there you go, that your measurement is going to be our predicted value for the elongation. Okay, so approximately like something like that. Then you will need to calculate the slope of the trend line. The slope of the trend line must be calculated by picking 2 points on the graph. Okay, so probably I may prefer to choose one point. This I'm representing it by some kind of a star, and then I will pick another point maybe that is convenient on the graph, maybe this. Okay, so you are not always bound to select like those 2 points. Doesn't matter. Student A may choose those 2 points, student B may choose other locations, like something like this and like that. Okay, so keep in mind that like don't make the points like close to each other. Don't select points that are very close to each other. All right, so once you do that, then the second activity in this laboratory experiment is to construct your graph. So for instance, by having data, let's say your set of time data is given, a set of this speed data is also given here. So the way you will proceed is like this. So first you need to write a suitable title. The suitable title from here is like, it says a falling object. So probably we are trying to predict some kind of falling acceleration or something, but we already given here a title for our experiment. So therefore this will be selected as your title for your experiment. Okay. And then second question is write the name of the axis and their values in parentheses. So this will be your x or horizontal, and this will be your y or vertical. All right. Then you need to find your data range for the time axis. We already know how to find data range. What is your minimum value? In this particular case, your minimum value is 1, your maximum value is 9. So therefore, your data range is going to be this, right? And then how many divisions do you have on the graph paper? So you look at your graph paper, like for instance, I already gave you a graph paper here. So look at this graph paper. How many divisions do you have? Like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So therefore you have 100 division points. So how many do you have here? 100, right? So therefore you need to find your v value. Your v value is going to be this, right? So but this is what, 0.08, but is 0.08 a convenient value? I don't know. I mean, that's up to you probably to choose, because like 0.08 isn't really that much of a convenient value, but you need to find a convenient value that is more than 0.08, but also like it's listed like in those like I think on page where are we? This is page 23. If you go scroll up to here, if you look at it here, for instance, for our experiment, I would pick this value, right? So you go ahead and then pick that value as your convenient scale. Okay, then you do the same thing for the y-axis. Okay. So your data range for the y-axis is going to be this guy minus this guy, right? So therefore, that's your data value. Where do I put it? I think, what is it? 86 minus 8 probably, right? And then the number of divisions, you come and count it on the graph again, like in the y direction. 1, 2, 3, 4, 5, 6, 70, 80, 90, and then 100. So you have 100 divisions like in the y-axis. So therefore the number of divisions will be that. Okay, then this then you need to calculate your v value. Your v value will be 78 excuse me, 78 divided by 100, that would be 0.78, right? So 0.78 isn't really a convenient scale, then you have to take it as one. Then now you go ahead and then like you put those numbers on your graph. So the scale on the x-axis is 0.1. What does it mean? Like that means this little guy is 0.1, then the second one will be 0.2, 0.3, then, but instead 0.4 and so on. When you reach here, you will reach 1. And here 2, here 3, here 4, here 5, here 6, here 7, here 8, here 9, here 10, right? But on the y-axis, what is your scale? Your scale is what we found is 1. 1 means like every little small grid is 1. 1, 2, 3. But you don't have to write like that. Otherwise, you will crowd your graph. So rather what you do is 10, 20, 30, 40, 50, and so on and so forth up to 100. Okay. Then once you do that, like what you're asked to find is probably what you're asked to calculate is like then indicate the time and speed axis on the y-axis. We already did. We found the scale. Then now we plot the points. Keep in mind, we already know how to plot the points. First data, for instance, is 1,8, right? So therefore, what you can do is like 1 on the x-axis, you draw a vertical line on 1, and then you draw a horizontal line on 8. 8 is here, then the 2 points that are mid, that's your first data point. Okay, and then you keep on representing the other points, and then you find the slope eventually. Okay. So then activity number 3, probably you might not really have that much of a time. If you will be able to do up to here, then you know, for today's experiment it should be pretty much sufficient. Okay, thanks.